Hello and good morning. This is the third section in chapter 4 where we actually start using postulates and theorems to prove that two triangles are congruent based upon the information we're given. Okay? Two methods today are side, 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 angle, side. Get to in a second. Additional resources for today, and it's very important you go over these. The PowerPoint. Chapter 4, Section 300 notes, and also the Chapter 4 notes, pages 7 to 12. Okay, we'll discuss what I'm going to in a different way. The first thing we have to deal with, as I told you at the end of the last lecture when we were showing the one proof, you're never going to get that much information. You're going to probably get two items, and you'll have to prove the third, because all of our methods require 3 items. Okay, and it's a very unique situation about triangles. Okay, if I have two sides that are identical in length, the third side has to be in a specific range of lengths or it won't work. And we will definitely get into that later for triangles. Okay, but right now understand these work together on a specific method. Okay, so the order of the letters, side, side, side is kind of obvious. The 3 pairs of sides have to be equal to each other. Side, angle, side. The angle has to be in between or formed by the two sides that are congruent. So let's look at ways that we can prove that items are congruent. Okay, and these are all items, methods, concepts we've dealt with already. Nothing new here. The first deals with the reflexive property. The reflexive property says anything's equal to itself, right? Well, it's most commonly used for triangles when you have a side that is common to both. And we just say AB equals AB, reflexive property, and that justifies it. Okay? Another thing we'll be able to see are vertical angles. If you have triangles that are joined together where their sides intersect like that, you're going to have vertical angles which are equal to each other. We know that. So we would say angle ABC congruent to DBE. Reason they're vertical angles. Okay? If you deal with parallel lines, we know all the different relationships that angles will have when lines that form them are parallel. The most common you'll see are alternate interiors. So if I have two sides of a quadrilateral here that are parallel, remember, okay, the arrowheads tell you they're parallel. So if this is parallel to this, that common side between the two triangles is also a transversal, which means that this angle and this angle are equal because they're alternate interior angles. Okay? And that's a pair of angles you're going to have to show the triangles are congruent. When we have perpendicular lines, first off, perpendicular lines are going to form right angles in each triangle. So we know all right angles are equal, so that gives us a pair of angles. Okay? The reason we're going to use is one of the theorems. Okay? And you don't have to go back and try and remember what number it is. It's this one. Perpendicular lines form congruent adjacent angles. And that sets you up right there. Okay? The last methodology, reasons, whatever we want to call them, deal with bisectors and midpoints. Bisectors create congruent angles. If I bisect an angle, I'm left with 2 equal angles. So, if BD bisects angle ADC, then angle ADB is congruent to CDB. Definition of an angle bisector. Okay? Same thing for a midpoint. If you're told, okay, since a midpoint is the middle of a segment, that means I've got 2 equal segments. Okay? So if B the midpoint of AC, then AB is congruent to CB. That's the definition of a midpoint. And these are kind of easy to use. We're going to go over several here. I've got 6 pairs of triangles for us to decide whether they're congruent or not, and then I've got 3 proofs for triangles that our job is to prove that they're congruent. Okay? Today we talk about methods. There are 2 postulates we're introduced to today. The first is side, side, side. Okay? If you can prove the 3 pair of corresponding sides are congruent, then the triangles are congruent. So, the ones correspond, okay, and also in the chapter notes, you're going to see what the markings are. Okay? The ones correspond, this tells us they're equal. The 2s correspond, they're equal. 3s correspond, they're equal. Those are congruent triangles. On this one, these are equal, these are equal. We proved that those are equal. Okay, remember that's a reflexive property, the common side. Okay, those are congruent triangles because side, side, side allows us to say that. The side angle side, yes, it is important the order of the letters. The A in this case has to be between the 2 S's. So if you can prove that 2 pair of corresponding sides are congruent and the angles included between those sides, then the triangles are congruent. So here's what it looks like. We have a pair of congruent sides, angles, sides. The angle is formed by the congruent sides of each triangle. That A is in between the S's. Here's another one. Here's a use of vertical angles. Okay? In this particular type of problem, you will be given probably the 2 pair of sides. You've probably been told this is congruent to this is congruent to this. You would prove that those 2 are congruent. You would say the triangles are then congruent using side, angle, side. Here, we'd be given these sides. Okay, so there's 1 pair of sides. We would either be told these angles are equal or be told that that's bisecting, which would give us the ability to say, oh, they have to be equal. Then we have a common side. There's the second side. Side, angle, side. Okay? No, I don't expect you to be an expert yet. Okay? Here we go. I've got 6 pairs of triangles. And the type of directions you'll see are this. Determine which postulate can be used to prove the triangles are congruent. If not possible, we just write NP, not possible. So look at this first one, okay? This first one right here has 2 sides given to us, 2 angles given to us. We can prove that this pair of sides, okay, since BD is the side of each triangle, now I have side, angle, side. Okay, remember, we have a common side to the 2 triangles. That's going to be another side. Up here, another example of it. Okay, we've been given 1 pair of sides, a pair of congruent angles. Doesn't matter if they're 90 degrees or not. And we know that BD is common to both triangles. This is another example of side angle side. Okay? This one. We've got a pair of sides. We've got another pair of sides. We know this pair of sides is common to both. That is the side, side, side postulate. Back to here. Okay? We know that this is common to both triangles. Okay? But look at this. A pair of sides, a pair of sides, a pair of angles. Is that pair of angles between the sides that are congruent? No. We can't prove those are congruent. Okay? Do we say that they're not congruent? No, they may be, but we can't prove it because we don't have information that fits our postulates. And we can't just change things to fit them. Okay? Next, here we go. Pair of sides, another pair of sides. We know vertical angles are equal. Pair of sides, pair of angles, pair of sides. Okay? Next, nothing given to us as equal. Okay, so we're going to have to think a little bit. We have a pair of parallel sides right here. Okay? Parallel sides cut by a transversal, alternate. Interior angles are equal. Okay? Next, I've got a common side. Another pair of parallel sides gives us this. Is that side, side, side? No. Is that side, angle, side? No. Does this fit either of these methods we have? No. Can it be a pair of congruent triangles? It could be, but we don't have the technology. Okay, we can't do it yet. Let's go to the proofs. Okay. So, proof one. Okay. Given RS is congruent to TS. Okay. If it's given, we can mark it. And that's what I like to do right away, because now they start looking like the diagrams once you start marking. RS congruent to TS. Okay? V is the midpoint of RT. Okay, so we've got a midpoint. Okay? We also have a common side. Can we prove those triangles are congruent? Yeah, we sure can. We've got side, side, side. We've got it. Okay? Now we're going to put it together. Right? Okay, so our first one. We're just going to put our givens, okay? Yes, I'm abbreviating. Okay. Okay, now, what did this allow us to say? It allowed us to say this. Okay? And since the midpoint is given to us and allows us to say this, there we have our reason. Okay? Now, what was the third item we had? Well, we said that this side was common to both triangles, and it is. That's how we write it. And no, I'm not going to write the reflexive property of congruence. Reflexive is fine. It means you know what you're doing, and if you put that much, you can tell, you show me you know what you're doing. Okay? And now our last step. What allowed us to say this? Side, side, side. There it is. Okay, so we've proven the congruence of these two triangles. Okay, now, yes, this triangle looks strikingly similar to the one we just dealt with. But because we have different information, we're going to have to use a different method, maybe. Okay, in this, NP and PM are equal. So there's our given information. NP, PM. NP is perpendicular. Okay. Can't phase us. Perpendicular lines form right angles. Okay. Now, we got a common side. So look at what we've got. Pair of sides, a pair of angles, another pair of sides that we've proven or can prove are congruent. That's going to be side, angle, side. Let's put it down. Okay? Do I have to put the two givens together? No. In fact, sometimes it's better to split them up, but in this case, we can put them together and that's fine. Okay. The perpendicular lines gave us the right angles. Okay? So, we write it as the angles written out, and then we go back to one of the items we dealt with. Like I told you, it's a theorem back there, but we just remember perpendicular lines. You want to see abbreviation at its finest? Perpendicular lines form congruent adjacent angles. It was written up there already. Okay? If you got to look back, you got to look back. Then we have our common side. Once again, reflexive property. Okay. Now, we said we've taken all of our marks and put them into terms. So now we just have to say, okay, we've got our triangles and they are congruent with side, angle, side. Okay, here we go. Okay, so there's our next one. This is usually when people ask me, do all proofs have 4 steps on them? No, it's however many it takes. I mean, if we look at this one, we could have split this into 2 different steps, would have made it 5 right off the top. Same over there. Okay, it all depends on how many it takes you to get your logical point across. Okay, our last one for the day. Okay, here we go. On this one, we have a 4-sided figure. Okay, given to us. AB is equal, and that'll come to play in a second, CD. It also tells us those same 2 sides are parallel. Please, please, please don't think that because 2 lines are parallel, they're equal. Okay? Because this is parallel to this, and they're not equal. They're not congruent, they're not the same. Okay, so here we go. We've got parallel lines, a transversal. That means we have a pair of alternate interior angles that are equal. We also have, there's another pesky common side. That's all we can mark. Really, that's all we need to mark, because look at what we've got. Sides, angles, sides. That angle is formed by those sides. This angle formed by this side. We're done. We have side, angle, side. Let's write it. Now on this one, I'm going to separate the givens, and you'll see why in a second. I do that because we're trying to prove triangles are congruent. So I do have to rewrite this as congruent segments. And here's what I'll do. It's not difficult. If 2 segments are equal, then they are congruent. It's that easy. We just call it the definition of congruency. If things are equal, then they're congruent. If they're congruent, they're equal. Okay? Our third step, we'll use our next given. Okay? I'm using, because the parallel lines allowed me to say those angles are equal, that's what I'm using. Okay, alternate interior angles are congruent. Okay, so this is our common sides again. Okay, there's the reflexive property, and that is all the items that we marked up there, so now we're done with this, and we can go to our last step. Okay. Okay, there we have it. There are 3 proofs for you to peruse at your own leisure. Okay, folks, not the easiest section in the world. In fact, this chapter is going to drag you down a little bit and drive you crazy. I'm going to try and keep numbers in it, and come test time, it's going to be a fill-in-the-blank proof. But I'm going to make you do some just to experience it, to get yourself an idea of lining up the logic for the problem. Okay? We're going to get through this. Work. See you in a bit.